All right. So we will have second period exam tomorrow from 9:10 to 10:35. All right. Make sure your laptops are charged. Make sure you have a calculator with you. Everybody needs a calculator. I won't have any to borrow. I apologize. All right. Which question did we leave off with yesterday? It was in the 20s. Yeah, it was in the 20s. But this is also from sixth period, so I don't want to skip over one if we haven't done it yet. Was it around 24 or 25? Yeah. Any questions on those two proofs after checking the key?
Our table thinks it was like 20.
Oh, earlier.
Yeah. Yeah.
All right, we're gonna need to move quickly then. I want to make sure I answer any questions you have. So, for one like this, did we do 20?
Wait, no, we stopped.
Yeah, we stopped at 20 because you were telling us that that's so we were ready.
Okay, so we did 20, but that's the last one we did. Okay, next one. We've seen pictures like this one before, but there's different things that can happen. I'm just telling you a broad generalization. We saw one like this on a quiz, and we were told that AK, watch up here, bisects angle JKN. If you bisect an angle, you get two congruent angles, correct? That's not this case. That's not this one. Don't say that unless they use the word bisects an angle, like angle bisector, all right? This one, they said A is the midpoint of JN. Well, here's JN. If A is the midpoint, then JA and NA are congruent. Definition of midpoint. However, I bet you can understand for the same reason, you can't say this unless you're told it, right? Like on the quiz, you saw angle bisector. But some of you put these segments were congruent. All right? We didn't know anything about those segments. This one, we do. So you just have to use whatever you're given. Don't try to assume something is true that's in the picture that's really not true necessarily. All right? So for that one, you're going to have definition of midpoint. You're given another pair of sides are congruent. You got the reflexive property. These should have been congruent by SSS. Okay, awesome. Moving on. 22. Do we want to talk about 22 or are we okay? Mrs. Wolf solved it one way on the key. Someone else sixth period did it a different way. I think Mrs. Wolf did consecutive interior and linear pair and then did a substitution. I had a sixth period student ask, can I do a vertical angles and a linear pair theorem? And then alternate exterior as well? Yeah, that's fine too. So they did linear pair, they did alternate exterior, and I don't think they did vertical angles. I take that back. They didn't use two at all. They did alternate exterior and then linear pair and then a substitution to say 1 and 3 are supplementary. How?
Would it be okay if I said vertical angles and that made 1 and 2 congruent, and then I said consecutive interior angles, and then I substituted, because I made 2 and 3 supplementary, and then I substituted 2 for 1?
Yes. Yep. Okay. And then converse consecutive, not converse, I'm sorry, definition of supplementary, yeah. All right. 23, listen, train your eyes. As soon as you see I'm proving the lines are parallel, I'm going to use a converse of something. All right, I have to use a converse. So you're given 1 and 2 add up to 180. You know 1 and 3 are congruent. If 1's congruent to 3 and 1 plus 2 add up to 180, then 3 plus 2 add up to 180. Oh, look, those consecutive interior angles are supplementary. The lines have to be parallel converse of the consecutive interior angles theorem, or same side interior angles, whatever you prefer. Got on that one? All right. I'll make sure we talk about those. It's been a while. Equilateral, therefore equiangular. See how it's pointing to an angle? The angles in an equiangular triangle are 60, set it equal to 60, and solve. Jackson.
Could you scroll down through for number 22? All right, thank you.
Questions on 26. All right, 27. There was some weird stuff going on. Some of you tried to set these two equal. We don't know that those two are equal. All right. Then some people tried to set 6y plus 1 equal to 6y plus 1. Okay. Now that we're kind of getting further along in our math careers, what's going to happen? What can we generalize and say is going to happen anytime you set an expression equal to itself?
It's gonna cancel out.
Yeah, and you're going to end up with like 1 equals 1, or 5 equals 5, or x equals x, which last year in algebra you guys called all real solutions. Remember that? All real? This is not what you should be doing. I'm just reminding you. If you do this, you should stop yourself and say that's not going to end well. Okay. What would you do to solve for y? Or to solve this in general?
You would do 6y plus 1 plus 6y plus 1 plus 21y.
That's the correct way to solve the problem. What's the right way to solve this thing that I'm doing that is not correct that you should never do?
Put them over.
Subtract 6y from both sides, sure. 1 equals 1. Does that help you? No. What does that mean? It means it doesn't matter what you plug in for y. These are always going to be equal. All real solutions. All real numbers. Can y be 100? Yeah. Can y be 1,000? Yeah. So did you get a solution? No. All right. So that's not the right way to do it. Let's figure out another way. Well, if this angle is also 6y plus 1, then Tally says all three angles should add up to 180 degrees since they are angles, correct? Combine the y's, combine the numbers, solve for y, get your answer. All right. Are you guys okay if I do this, the major setup of the problem, because you have the answer key in front of you, like you have access to it? You okay with that? And if you have trouble solving one of these, just let me know. I'll solve it. But just to make sure we get through all of them, the setup, I think, is the biggest part for a lot of you. All right, next one. 1 and 9. The little trick we had for this was, what's the vertex of angle 1? Well, it's right there. What's the vertex of angle 9? Right there. What line touches both of them? N. That's the transversal. So N is our transversal. And those are called, what did you call those ones? Corresponding. Good. Are those corresponding angles congruent? Someone said we don't know. And that someone is right. We don't know. Only if these lines are parallel. And probably not. Can't go off of looks, right? Can't go off of looks, but we're not told those are parallel. It's pretty obvious they cross. So those corresponding angles are not congruent in this case. All right, 29, if you need to remind yourself, this is called the triangle mid-segment theorem. We just learned this in section 6.3. There were two things you needed to know about a mid-segment. They are parallel, and the mid-segment is half the length of the side it's parallel to. Or it takes an n plus 14 and another n plus 14 to equal 3n plus 12. It takes two of those. Not one of them. It takes two of them. And how can you recognize the mid-segment? Well, it connects the midpoints of the triangle. That was one of the ones where it wasn't the median. This is not a median. A median connects the vertex to the midpoint of the opposite side. Okay. The mid-segment connected midpoints of sides. Midpoints. And then you get that the mid-segment, and you can say it's half the length. Good from there. All right. All right, this one's been a long time. This is one of the first things we did this year. If I start with that and I multiply 4 to both sides, I'm using the multiplication property of equality. Multiplication property of equality. What happens if you divide both sides by a number? Division property of equality. We used those a lot when we first started proofs. You probably don't even remember what's the first proof we did. They were algebraic proofs, where all we did was solve for x and gave a reason for each, right? Where we subtracted 5 from both sides, multiplied by 4 on both sides. We gave a reason like the multiplication property of equality. Christian.
Are the algebraic proofs going to be on the exam?
I don't think so. Did you say yes?
Yeah, I like the ones we're doing now, like
Oh.
SSS.
Okay. All right. Any other questions on the properties? Properties. Next. We're okay with do you want to see let's group these together. This slide I have 31 through 34. You have the answers. Would you like to see any of these worked out? Probably 34. Yeah. I think students are still struggling with that. Were you okay with drawing a picture for 31? Solving that one? Okay. Was 33 okay? Page.
I have a question on 32.
Yeah.
B and B are really like similar to me, so how do you like tell the difference between the plane and the line?
Well, okay. So, did she put line for E?
Yeah.
Did she put plane for B?
Yeah.
Okay. So how to remind ourselves of which one's which? Because they're both cursive. How do we name a line? There were 2 ways to name a line. Let's go back to that. Callie, do you want to answer that one or that one?
I was gonna ask if B was a capital M.
It is a capital M. Yep. If that's on the exam and you're not sure, that's something you can ask me. Is this a capital or is this lowercase? Do they still teach you guys cursive?
No.
They
I can.
taught me for 1 year.
Well, I mean, this is great evidence for why we should learn cursive.
I taught cursive for 1 year.
All right, real quick. We need to move. All right, 2 ways to name a line. 2 ways to name a line. You remember? A lowercase cursive letter like L or M. All right. Or 2 points on the line. A, B, C, D. Right? Remember that? Line. Plane. There were 2 ways to name a plane. 3 points on the plane that were not collinear. That were not in the line. 3 points on the plane. Or capital script letter if it was in the corner. So like if this is our plane and points A, C, B, you could name it that. Or if there was a capital script letter in the corner, you could name it plane M. Good page?
Yep.
Awesome. All right. 33 or 34? Both or one or the other? 34. All right. What kind of triangle is A, B, C? How would you classify it? Equilateral. And so therefore it's also equiangular. Therefore, all 3 of these angles are 60. An equiangular triangle is always going to have 60, right? How else can your 3 angles add up to 180 and they're all 3 equal and they're not 60? You can't. They have to. If they're all 3 equal, they're all 360. always. But it's also equilateral. So 10, 10, 10. Did you solve for, was it Christiana? Did you want to see this one? Or is it McKenna? Page? Okay. Did you solve for y or x first? Do you remember?
I solved for y.
Y. That's probably what I would have done. 3y minus 14 equals 10 to solve for y. But then x, you have to use the linear pair theorem and say, oh, 60, 120. And look at this triangle over here. This one is, how would you classify this one by sides? Isosceles. You see the tick marks? Do you see this tick mark right here? It was already there. I drew it in, but it was already there. It has to be the same as that one because these tick marks are in the same picture. They have to be congruent, right? And because of this being a shared side in an equilateral triangle, it's also a between side. So if these two are congruent, then the base angles of an isosceles triangle are congruent. Well, this obtuse angle is already eaten up 120 degrees. There's 60 degrees left in the triangle, and they're split between two equal angles. Each one of those are 30. So you should have set 5x equal to 30, divide by 5, and get x equals 6.
Can I say 5x plus 5x plus 120 equals 180?
I guess so. Yeah. Questions on those ones? All right. Next one. I think this one is accidentally graphed wrong in the key. On the key. All right. I think she accidentally graphed 2, 7 as 2, negative 7 down here. Is that correct? So let's do this one together. B and C. All right, let's read the directions. Classify the triangle by side length. Then determine if the triangle is a right triangle. All right, so there's 2 steps to this problem, okay? And I might not be this nice on the actual exam. Where did you realize that 2, 3 and 2, 7 are right above each other? Yeah. And then 2, 3 and 6, 3 are on a horizontal line. So we have a vertical and horizontal line come together. How do you show that they're perpendicular? We know they are. This is an easy one. How do you know that? How do you know those ones are perpendicular? Slopes, right? Now one's undefined and one's 0. But you learned in Algebra 1 that undefined slope, vertical line, horizontal line are always perpendicular, right? So what if I slightly turn this? Well, then you're going to have to use the slope formula or count. I would just count. I'm okay if you guys count on the graph, rise over run. If this is slightly tilted like this, you'd have to find the slopes of both and show that the slopes are, yep, and they are opposite reciprocals of one another, right? Which makes them perpendicular. You okay with showing that work? All right. Now for this one, we can say yes. The slope of AB is 0. The slope of AC is undefined. So that makes it a right triangle. Next, let's classify by sides. This side is 1, 2, 3, 4. This side is 1, 2, 3, 4. Okay. Now, what if they're not stacked vertically or stacked horizontally? You're going to have to use the distance formula. And we're still going to have to use the distance formula just only one time here. All right, so we're going to have to do CB. So C and B, we're going to do 2 minus 6 squared plus 7 minus 3 squared. What's negative 4 squared? 4 squared? Square root of 32. Just like, I don't know, 5.5 or 5 point, something like that, right? But if we ask you to write it, do we ask you to write it in a certain way? I did not ask you to write it in a certain way. So you can answer this as got a pair of 4s. What comes out? Radical 2. 4 radical 2, or did someone type this in the calculator for me?
It's like 5.6.
5.6. So that was CB, BC, 4 radical 2, or 5.6, you said? Thanks. AB was 4. AC was 4. So this triangle would be classified by as what? Isosceles. Okay.
Are we like most likely in between the way you write it? Like either the radical or the.
I forget how I asked, but if I didn't say it, you have your choice. You could have either one of those. I would have accepted. Okay. You should be able to do it both ways. But if I don't specify, you can answer it either way. Questions on that one? With correct work. All right. With correct work. All right. 36. A is -3, -3. B is 7, 2. Find the coordinates of point P along the directed line segment so that PA to PB is 1, 2, 4. PA to PB is 1, 2, 4. Okay. Now, if you just look at this picture, I had some people who were like, well, 1 to 4, maybe P is going to be in here somewhere. I'm just going to graph it there and just put in. You won't get any points for that. I'm sorry, but we did this a certain way. It has to have work. Okay? So, if we have to remind ourselves, what does the ratio of 1 to 4 mean? It means there are how many pieces in this pie? 5. I get 1 piece. Elizabeth gets 4 pieces. So I get 1, what fraction of the pie? 1/5. Elizabeth gets 4/5. Lucky. Unless it's like a banana cream. That's like, you can have it, Elizabeth. All right. Or pumpkin. You like banana cream?
Yeah.
Right.
You just gotta find someone who makes it good.
Yeah, that's true. All right. So here's what I'm thinking in my mind. All eyes up here. If I know how far the distance is horizontally to get underneath B, what fraction of the way am I going to go? 1/5. If I know how far up and down I need to go, what fraction of the way am I going to go? 1/5. And the second question, are you ready? If you don't know this, write it down. Okay, remind yourself. The second question is, am I going from A to B, or am I going from B to A? A to B. Okay. All right. So let's find the horizontal change first. And this is a great way to show your work. Horizontal change from A to B. Well, I can do it 2 ways. I can count, or I can look at the x values and find out how far apart they are. How far apart are -3 and 7? How far apart are -3 and 7? 10. So if I have to move, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm going to the right 10. But that would be the whole thing. I don't get to go the whole way. I'm only going 1/5 of the way. So my horizontal change from A to B is 10. So I'm going to go 1/5 of 10. What's 1/5 of 10? 2. Does that mean my x value is 2? No, it tells you to go 2 units from letter A, which is an x value of -3. Right? Watch up here. This tells me I'm moving 2 units to the right. From A. Don't go from 0. Go from A. I'm going from A to B. All right? Second part. Vertical change from A to B. Well, my vertical change is up 1 2, 3, 4, 5. I can count. Or I could look at the y values and say from -3 to 2 is 5 units up. 5 units up. So 5 is my total vertical change, but I'm not going to go all the way. I'm going a fifth of 5. What's a fifth of 5? 1. So I'm going right 2 and then up 1. Okay, well, here's the way I think of it. Point P. I take where I started and then how many units I moved. Where did I start? Which x value did I start at? -3. And then I moved right 2. Ready? What's the y value I started at for A? -3. And then I moved up 1. So point P, what's -3 plus 2? -1. What's -3 plus 1? -2. -1, -2 is my point P that is a fifth of the way from A to B. Does that make sense? Now, I should have looked at the key, how Mrs. Wolf did it. Did she use slope? Or did she do it this way also? Did it this way? The book uses the idea of slope, which is the same thing we're doing. It's a different way. I actually like this way better. You're welcome to do it either way. It doesn't bother me. All right. Now, the part that I think you struggle with is some people were struggling with was the ratio. Let's practice really quick. What if I say the ratio is 2 to 7? You'd do 2/9 of the way, wouldn't you? What if I say it's 1 to 3? You go a fourth of the way. You good? Awesome. Jackson.
That equation you did, that is -3 plus 2 and -3 plus 1.
Yeah.
Where do those numbers come from?
-3 was where I started. I started at an x value of -3. -3 is where I started for the y value. So I started at A. This came from A. A was -3, -3.
Oh, okay.
So I knew if I started at A and I added on my horizontal and vertical change, I would end up at P.
Okay.
All right.
Thank you.
Thank you for asking. Questions on that one? Not really. It's not like a really tough problem. It's just, oh yeah, I forgot we did that, or it's been a while. I need to practice that. So practice it. All right, practice it. There's some questions in the book that are odd numbered for those ones, and you can look at your answers. Check them in the back of the book. All right. These ones, I'm just gonna be honest. This is one of those things where you guys just need to study the rules for reflections or rotations mainly. I bet reflections you guys remember pretty well. Reflections are pretty easy to remember. You go across the x-axis, same x, opposite y's. If you go across the y-axis, same y's, opposite x's, right? It's the rotations that you guys need to remember. If you can remember it, they're pretty easy to do, right? Just take a look at those. And it was also brought to my attention, I think on 38, I think she might have had across the x-axis and then left 5. I think it should be across the x-axis and then right 5. Okay, if you chose that option. Tally?
It says for 37, I don't know what it's really asking because it says determine the following figures have line symmetry, rotational symmetry, or both. Like what figures?
The picture got cut out. That's weird.
Yeah, because
Yeah.
I didn't understand.
In a couple minutes, thank you. Nobody mentioned that. Do all of your papers not have that?
Yeah.
No, nobody said anything. All right. So I'll pull up the original. Sometimes when we take it from one document to another, the pictures get deleted. So if we have time, I will pick that up. Do you guys remember line symmetry? You could draw a line through it, and that would be your fold. If you could fold it on that line and it maps up with the picture. Rotational symmetry was where I took the star and I put a dot on the star, and it every time it hit another vertex, it didn't count if it took a full rotation to go back to where it started. That didn't count as rotational symmetry. It only counted it as if it rotated and hit a vertex on itself and lined up perfectly. That was rotational symmetry. All right. So we'll get to that. I'll try to find the picture on that one. Now, one of the things we missed a lot on the quiz when we did this originally was it has to map A, B, C, D onto E, F, G, H, meaning if A gets rotated down to here, it's now A prime. If D gets, did I say rotated? Reflected down to here, it now becomes D prime. Oh my goodness. If C gets reflected down to here, C prime. Now what has to be true? They have to line up accordingly. Where does A need to end up? E. Where does B need to end up? F. Now, do you agree 5 units over, A will be on E, and B, 1, 2, 3, 4, 5 will be on F. If they don't line up, it doesn't work. If your reflection or your rotation, your attempt at a rotation or reflection, doesn't match up the correct letters with what they're asking you to match it up with, it doesn't count. All right? Good with that one? Probably. Linear pair. I don't think we'll need to suffix. Awesome. All right. Which triangle congruency theorem proves the triangles are congruent? I'd like to practice this. We really struggled with this on the quiz. All right. This one is, who can raise their hand and tell me? Preston. A, S. Your choices are one of the 5 or not one of the triangle congruence ones. Those are your choices. Not congruent by what's given or congruent by, and then you tell me. Who can raise their hand and tell me which one this is? Page. SAS. Tyler, what do you think? Was that right?
No, Preston.
Preston, what'd you say?
Told him not to do it.
Don't do it. He wasn't going to. He saw it coming. I was like, I got this. He's about to set me up.
Remember whenever you wrote it based on your paper? I could have just said yes.
It's a bad word. Don't do it. SSA is not one of them. Okay? You got it wrong on the quiz. A lot of people got it wrong on the quiz. I warned you. Next time it's public embarrassment. I'm sorry. Okay? You have to stay after exams. You have to stand up against the wall outside. Okay?
SSA is not congruent.
All right. That is not one of them. It's the bad word backwards, and they work forwards and backwards. So don't do it. Don't do it. All right. Was that enough for the triangle congruence? Yes. Ooh! I got another one. I lied. You said it was enough, but it's not. Oh yeah? Oh yeah?
We don't know.
This is H. Thanks. Now I know what it is.
SAS.
What?
Yeah. You know the hypothesis.
I'm definitely gonna get there. Wait, can you show an example of HL?
HL would have.
HL.
HL,
I agree with HL.
not SSA. This is not SSA. This is HL. This is a special case. It doesn't happen really often, but when it does, it's special.
Okay. SAS, AAS.
All right, classify the triangle by both angle measure and side length. Ready? Angle measure.
How about one?
It is right. Shh. Hey guys, let's finish up. How about by side? How about by side? Scaline. Scalene. Westfall. Yes.
Okay, so I have SAS, AAS, SSS, HL, and what's the other one?
I don't remember.
I don't either.
All I remember is SSS, SAS, ASA, AAS, and HL.
So that's AS.
Come on.
I have a question. For 41, is it skimming because none of them are marked? Because I was a bit confused for that.
3, 4, and 5. They're all three different.
Yeah.
Scaling means all three sides are different.
And then it would, if it was isosceles, it would be marked on some of them.
Either marked with tick marks or it'd say like 4 and 4 and 5.
I was
It
confused.
isn't a triangle, but whatever. But what's that?
I was confused with the numbers. Okay, that makes more sense.
And I just told you the side lengths.
And then the line is right there.
2 ways to solve this one. You can take it the long way. You could add up all three, not sides, back up. All three angles to equal 180. Or you could use the corollary that says the two acute angles in a right triangle are
90.
that would make way more than 180 degrees. Complementary.
That is the
That's
same
the same
exact
thing.
thing.
What do you mean?
They were saying we both add up to 90.
Oh, add up to 90. I'm okay with
I
that.
didn't say that.
Well,
Complimentary is
that is
the
what we
preferred
meant.
term.
That's what I said.
You guys just said, I didn't say correct.
Back up. Shh. Hold on.
And I agree with
I'm not-
Brianna.
I'm kind of joking with you because it happens, and I want to make sure we're clear. If I said both of those angles are 90, you guys would correct me. If I said angle T and angle S are 90, do you see how that's a little unclear?
Yeah. Exactly.
Okay, ready? McKenna, how old are you?
15.
How old are you?
16.
Okay, let's pretend you're both 16. Okay? Okay. You're 8 and you're 8. You're both 8. Okay? That's different than like, if I said back up. You're 32. Okay? That's a better example. You're both 32. That's what I wanted to say. You're both 32. No, your ages add up to 32.
Well, I said that. All I know is those are 90 and
Okay.
Listen, I think we're kind of
I think we should.
taking a number. I think you guys would all get this right on the quiz or the exam. Right?
Yes. I would try.
Maybe not all.
So I got
All right, you should add them up to equal 90 and solve for x. All right, listen. There is an online component. There is a paper and pencil component. It's going to be a blast. All right, just come ready to have fun. Back up, hey guys, quiet. Listen. Listen.
I like yours.
some people give us food.
Hey,
Why coyote?
just a warning. I know the comment about note cards, whatever. You were worried about it, or you were angry about it, whatever you want to say, whatever your emotion was. Okay, we're over that. We're past it. However, if you feel pressured, well, you need to get past it. If you feel pressured to do something rash, okay, and write equations or something somewhere and try to cheat in the exam, okay, I'm not saying anybody would do that. I'm just warning you. If you have something written somewhere, or you look somewhere else for examples, or whatever, someone else's paper, something written on your hand, a paper written somewhere else. Okay? It is a 0 for the semester exam. Don't put yourself in that situation. Okay? Paige.
So even if we get the exam and we write formulas, you're gonna count as 0? Or-
Wow, no.
Who said that? Who said that? That's not something you ever.
If I have it written somewhere else.
It's on your hand.
If you write it somewhere, like, and you're trying to be sneaky, like on a note card somewhere else. Tally.
But we're allowed to like look at the walls in the room or something, or would that like look like we're trying to
The walls and the
What would you have the wall? What do they have
Walls, is there any?
They can get some sound, but that's it. Well, why? You've been a great class. Oh, I'm cheating. I don't we don't have area or we don't. We didn't have this year. You are. I'm kidding. And it's okay, not everyone knows what a trapezoid is. Why would you turn your head like what? All right, so you're facing this way. Why would you turn your head 90 plus degrees to look at that? You're not seeing that.
No.
What can that possibly offer? We don't need to find this out. We don't need to. It's easy enough.
I only know